Welcome to the RevK shopping channel. Okay, not really a shopping channel. Wow, it's a squeaky chair, sorry. Not really a shopping channel, but as some of you know, I design a lot of small circuit boards and write a lot of software, and it's all open source, it's all on GitHub. And so I thought I'd do a little bit of a presentation on some of the various circuit boards I have available. So it's not quite call now operator standing by, but it is. We sell this on Tindy and Amazon, and it's open source. So let's get started. So in no particular order, let's start with one of these. Now, this is typically how they arrive, in a nice little bag. And if we open it up, you can see what this is. This is my audio recorder. Details on the screen, or something like that, I don't know. Details on the bottom of the screen. I'm not really very good at shopping channels. I haven't seen them for a long time, but you get the idea. Audio recorder. Now, I'm actually using one for the audio for this video. And what makes this nice is it's got two very high quality stereo 24-bit microphones. So it is stereo, although they are quite close together, so there's not a lot of separation, but it's there. It's got the ESP32S3 Mini N4R2, which is a dual processor ESP32S3. It has 4 meg flash, 2 meg of SPI RAM, so it's a very powerful S3 processor. Like most of my boards, they all have that processor, well, almost all. It has a USB-C connector. Now, almost all of my boards have USB-C. You can use this to power it, and you can use it for flashing new software and debug and so on. And it has a connector for a small 3.7 volt LiPo battery. And this is typically stuck to the back, so that it's got battery operated. Now, the same as the audio recorder I'm using is battery operated, but it can be operated and powered by USB if you want. It has a button, and it has 4 multicolour LEDs. Again, a lot of my boards feature these LEDs, usually just one for status. It's full RGB programmable WS2812 style LEDs. And this particular board has on the back an SD card slot for micro SD and those 2 microphones, which face through a hole forward on the board. So this is my audio recorder. Now, a nice thing about this is it's got this hook at the top, and the idea of this is it can clip onto a shirt button or to the collar of a t-shirt and allow you to keep it there for your recording throughout your video. So video bloggers and the like, perfect for you. So that's the first. Very simple. Right, what have we got next? Well, these go together, so let me get them all out. So I've got three bags now. So let's start with this one labelled IronMan suit. Hopefully that's got you suitably intrigued. So here it is. Now remember, these are all open source. They're all on GitHub, the circuit board design and the software. Why is this called IronMan suit? Well, again, it's got that powerful ESP32S3 Mini N4R2 processor, an SD card slot typically for the sound media you're going to use with this board, and a USB-C which you can power it from. And this board is intended to be powered on USB-C. It would normally work from a USB-C battery pack. So you've got nice battery packs. And this particular board is designed to go in the suit of an IronMan suit, inside the suit. Now, it's got a lot of connectors. You'll find a lot of my boards use these Wago connectors. They're very nice. You push down on the little contact there with something pointy, not too hard, and you poke your wire in. And again, you can push down to take your wire out, and they take wires really easily. They're a lot easier than screw terminals and a lot smaller. Now, the reason this is designed for an IronMan suit is, well, I know someone who plays Iron Man for parties and things like this. But it has got 4 of these 3-way connectors, and each of them has power straight from the USB. So the 5 volts straight from the USB. Now, if you put in a nice battery pack in there, that will be able to supply quite a bit of current. And the reason you need a bit of current is because this isn't just for LED strips. This can also be used to work a servo motor like this directly. And that's also why it's got big capacitors, one on each of the outputs. These are there to make sure it can power that servo with its nasty little power spikes that it gets, and it works quite well. It has got microphones, which actually aren't useful for IronMan, but it's also got a speaker driver. So left and right output for speaker. So why do you need a speaker? Well, the IronMan suit has speakers in it, believe it or not. And they're these. Let me find them. That's the speakers we're using. 4M speaker, really quite loud, very nice. So, obviously, if you don't have an IronMan suit, why do you want this? Well, it's 4 separate 5-volt and signal outputs. So if you want to do any robotics with servos, it's perfect for that. If you want to do LED strips, it's perfect for that. It has 2 separate button inputs as well. So you can have inputs. The IronMan suit has a button on it. So yes, that is designed for an IronMan suit, but useful for lots of other purposes. Now, I said these first few boards go together. The reason is, as well as the IronMan suit, I must apologise for my chair squeaking. I'm not sure how well it's going to come out on the audio. I really hope it doesn't. Okay. The next one that goes with the IronMan suit is labelled IronMan gloves. And this is another much smaller board. So here we go. Now, this isn't designed to work off a USB battery pack because the gloves don't have space for a big USB battery pack. There's loads of space in the suit and the helmet. Interestingly, the helmet uses the same controller as the suit. So there's one in the helmet, one in the suit. But this does have a connection for a reasonably large LiPo 3.7 volt battery. And in the glove, this and the battery go next to each other in the palm of the glove. It has contacts for a button, which goes under your hand in the glove. And it has these, which are to drive an LED strip. So this connects to the battery and has an output. So this isn't a high voltage, this isn't 5 volts. It's running off a 3.7 volt LiPo. So this is 3.7 volt power for an LED strip and 3.3 volt signaling. A lot of LED strips wouldn't do 3.3 volts. Most of them need at least 5. But this is designed specifically for the next board, which is IronMan LED ring, which looks like this. And the IronMan LED ring is a ring of LEDs in the palm of the hand. I've also got some little plastic diffuser discs that go over it. And little contacts to solder on the back. This is 88 LEDs in this ring, all full colour. So, that's available on its own. It's a useful LED strip. It will work from 5 volts or 3.3. So that's a nice LED ring. The IronMan gloves are a nice LED controller that works from battery. So it, again, can be used for things that aren't IronMan specific. And the overall effect of all of these put together is best explained by IronMan himself. Now, you'll notice the speakers in the suit working well there. When the helmet goes down, it goes clunk, and that's an audio file on the SD card that the speakers play, and it's linked via Bluetooth from the helmet to the suit. The glove effect, again, there's a sound effect with that. That's linked with Bluetooth, so when he pushes his hand and presses the button, the light lights up and the sound effect happens at the same time. So that's the IronMan setup. And I'm sure those boards are actually useful for a lot of things other than IronMan. So what do we have next? Let's have a look. Okay, I think I will do LED controllers next. So this is one LED controller. I have another one there and another one here. So I have here 3 separate LED controllers. We'll start with the USB-A LED controller, which looks like this. Now, that tab there will go straight into a USB socket directly. So the whole thing literally plugs into a USB socket. It has that same ESP32 S3 Mini N4R2 dual processor, really nice ESP32 S3 processor, which is good. It has high quality microphone and 3-pin WAGO, designed to go straight into an LED strip. So power, signal, and ground into an LED strip. It's also got this little bit here and says glue here. Basically, you take that off and glue it on there, otherwise it's not quite thick enough for USB. So you super glue that onto there to get it thick enough. And you've then got a USB-A plug-in LED strip controller. So that's my simplest. The next one is the USB-C LED controller. This is really quite nice. It's designed to be in line. So USB-C goes in one end, the LED comes out the other. And a nice small board. It's still got that same high quality ESP32 S3 controller. It's still got, like all of these, an LED, and as I mentioned, the other one has a microphone. The microphone's for audio reactive effects. Okay. What's nice about this, apart from its really slim line, is it is completely flat on the back, which makes it ideal for putting some double-sided tape, some nice 3M tape on the back, and sticking it like under the edge of a table or whatever, a shelf where the LEDs are connected. So you have the USB in, this stuck discreetly where you want it, and the whole thing just works seamlessly and controls your LED strip. So that's the USB-C LED controller. Now it's worth mentioning that both of these are also available with different software. So I sell them with my LED controller software. They can obviously be reflashed easily over USB to any software you want. ESP Home will work on them and so on. But my son has a site, Home is Where the Smart Is, HIWTSI.UK. And he sells them with WLED preloaded on them. WLED is a really comprehensive LED strip controller program, which you might like. So that's a USB-C controller. Put it back. And the last in the series of these small controller boards is the non-USB controller. And you might think, why? What am I talking about? Non-USB? Why no USB? Okay, the no USB controller is about the smallest you can possibly make one of these Wi-Fi controllers. This side has the ESP32S3, the power regulator, the LED, and the microphone, but it's tiny. The other side has the WAGOs. No USB. Now, how do I program this? Well, you'll notice on a lot of my boards, I haven't mentioned on the others, but they pretty much all have it, they have this TC2030 connector, and this goes in there like that, and you'll see it actually powers the board. So that provides USB to the board. Now, this is a specialised connector. It does cost a few tens of pounds. But this is a way you can reflash this board. But also, if you haven't got that, it's got 4 solder tabs there, which are USB. So you could wire a USB to this if you wanted to. But normally, you can just use the software that's on it and upgrade it over the air. So this controller works really well as a very tiny controller. And what people usually do is put a bit of sticky on the back of that to stick it to something. So it's not a flat bottom, but it does have the processor there, which is quite good. So that's the non-USB controller. And again, available with WLED preloaded. But I do have another LED strip. And this one's a little bit more specialised. You might have trouble seeing all of this. This one is the Coaster. 100mm wide, USB-C powered, 124 full colour LEDs. Now, it's got a microphone as well. I can show you what that's like made up. We do it with spacers and a diffuser, which I sell it with. And because it's got a microphone, it can not only do audio reactive, it can pick up when someone puts a drink on it. So if I do that, it wakes up. And I have an audio reactive coaster for my drink. Now, how cool is that? You can also get it with a slightly less opaque diffuser so you can see what's inside. Looks a bit more techy. So that's the coaster. So what else do I have in the bag of goodies? Well, I've shown this on another video about faking. And this board is faking remote, it's called. But it's actually sold more often as a general purpose environmental monitor board. Because, you can see a lot on this board, but not quite everything. This board has a light sensor, a temperature sensor, a pressure sensor, a CO2 sensor. And some of the later ones also have sound, a microphone for sound, and an infrared receiver. So it depends on the exact board, but most of the ones I'm selling are like this at the moment. So it's got lots of sensors, but also you use it with a display, and I do the displays as well. And if you plug the display in, it looks more like that. And it's a little 2-inch liquid crystal display, and it just plugs in, and you can screw it to the board. And that gives you a general purpose display for your sensor. Now, you might just want the sensor board on its own. It can be powered from USB or DC. It's got wagons for DC. It's also designed to work with DS18B20 temperature sensor probes. Now, these are great if you want to measure the temperature of something like the hot tub or water pipes. I've got someone who's got this on his cold water feed because he can monitor if there's a water leak. Because when there's no leak, the water pipe goes back to normal temperature, and every time you run the water it goes down. If there's a leak, it stays low. And he's got all of this tied into Home Assistant, so he can check for a water leak based on a temperature probe strapped to his incoming cold water feed. So there's loads you can do, and it all links into Home Assistant nicely. But it can also work as the remote control for the Fakin aircon controller modules. So a very comprehensive board. Now, the next one is very similar because it's actually exactly the same board, but without the CO2 sensor. And the reason for that is the CO2 sensor adds quite a lot to the cost. So if you don't want the CO2 sensor, this one, and this one does have a microphone on, this one can be purchased without the CO2 sensor just to make it cheaper, but it's got all the other bits on it and works with the display. So that's the remote without CO2. So what's next? We have a somewhat niche board. This is an access controller. Now, I might have to explain what an access controller is. This actually goes inside my door. And we've got them in like exit button boxes at the office. In my case, it's actually inside the door. And it connects to various inputs. I've got 6 inputs there. So the locks I've got good quality alloy locks, and they have sensors for whether the deadbolt's in or out, whether the door's closed, and so on. And it can also tie in with a button if you need an exit button. I don't on my house, but an exit button. It has an output for a relay, which can switch 12 volts at a couple of amps. So you can use that with a mag lock on a door, or to control the door lock, as I do. It's got 3 grounds and 3 powers, so it's easy to run power in and out. So often you have 12 volts to run this. You often have power in and then out to the lock. And these 4 pins go to an NFC reader, so that I can literally use a key fob to open my door with AES encryption and DESFire encoding. And that opens the door. And that has LEDs on as well. And it's got a little tamper switch here. You can probably just make out this tiny little switch here. So when it's inside a 3D printed case, There's a tamper switch, and it's also got a row of LEDs. Now the LEDs here are particularly useful when you're setting it up because these 6 inputs have 6 LEDs. So you can see as you close the door, it goes from red to green, that's closed, open, goes back to red. You can tell the sensors are all wired up and working, so it's really useful. So that's my access controller. It's actually typically part of a complete security system, alarm controls and so on. But this is the key circuit board that works the doors and the access control. As always, open source software available. 3D printed case designs are available for almost all of my boards, all on GitHub. So what do we have next? Let's go for intercom badge. Like this. Now you can probably tell where I was going with this. The oval. If you 3D printed a sort of triangle point case and a suitable connection for the button, you'd have a thing you can tap that has a microphone, speaker, Wi-Fi and battery. So yeah, it's got LiPo battery connection. The LiPo battery would go behind it. That same processor, 2 high quality microphones, probably only really needed 1, but it's got 2, a button and a speaker. Unfortunately, the speaker is a bit quiet. So this was my prototype. So it's not that this isn't useful, but I probably, if you were using this, I'd probably use it for something that only needed the microphones, not the speaker. It can just about be heard. You can probably make it beep nicely or something, but actually hearing what someone's saying through this speaker, sadly, it's not particularly good for that, I'm afraid. But the rest, it's really good for. Okay, so that is the intercom badge. What have we got next? Okay, these are labelled scrap recorder and they are dirt cheap on Amazon, okay? And the reason is, that looks familiar, that's my audio recorder board, no hook. Except when I ordered these, someone forgot to press the button for double-sided. So it doesn't have the SD card or the microphones on the back. So it's not an audio recorder. And soldering those on, just not worth it. So these are going for like $5 on Tindy. And the reason is they are really quite useful boards to experiment with this processor and useful. It's got USB-C. It's got 3.7 volt LiPo with battery charging. It's got 4 of those full color LEDs and a button. So this is great for anything you want, especially battery. You want to play around with battery operations. This provides you with a really nice development board for ESP32 based projects. And dirt cheap because I ordered it wrong. So next up, this. It's an audio board. It has connections for a speaker, and that's the speaker we sell with it. Really nice 4-ohm speaker, nice and loud. It's what's in the IronMan suit. It has USB. It has that same powerful processor. It has a nice button in the middle. Microphone and rows of LEDs. And what you do is you put it together and it makes this intercom. And the idea of the intercom is that you could put this in a box, you press the button, and that could make a SIP call. So I actually have code for a complete SIP client in this where you press the button and it rings you. And you can speak through the speaker and hear through the microphone from the other end of the call. So a cool audio board. Another fun one. This is not a small board, this is a bigger one. So I'll hold this up. This is an e-paper panel. It's 7.5 inch diagonal. Nice contrast, black and white. Stays on even when there's no power, as you can see, not powered. And this is an e-paper panel. I have these e-paper panels in bulk from Waveshare, so we sell the e-paper panels. But also, I sell this board to go on the back of it. And this has that same processor. An SD card slot for media. LEDs all the way around the edge. We supply it with this button fix bracket. You screw that into the wall and then slot this onto the wall so it's nice and easy to wall mount. It's got inputs and it can take DC power. This particular one's got a relay which we don't normally supply, but we do have an input, so you can connect it up as a doorbell. And I actually use one of these as my doorbell. I have a doorbell push next to it. I have some DC power comes in through the door, and you ring the bell and the sign changes to tell you leave a parcel behind the gate or whatever. So that's the e-paper available with and without the circuit board. And finally, this has to be the most niche product I've ever designed. You thought IronMan was niche? This is properly niche. This, I mean, the IronMan board's useful for other things. This pretty much isn't. This is pretty much only useful for the thing it was designed for. This is an ASR33 teletype controller board. Yes, I have an ASR33 teletype in my hall. It is probably slightly older than I am, which is saying something. And it uses 20 milliamp current loop 110 baud communications. And so this has contacts for 20 milliamp current loop. It's got a built-in 20 milliamp current source, although it can work with an external current source if that's how your teletype's set up. It's also got outputs that you would wire to a solid-state relay for power and motor for the teletype. So it can turn on the teletype, turn on the motor and manage it all for you. It can take DC supply or work off the USB. Mine runs off USB. It's got a button, which isn't generally very useful because it's also got an input that you would wire to a button on the teletype. So you'd have a button on the teletype and it turns on. And you can connect to it over TCP, you can connect to it over MQTT, you can make it connect to something over TCP. So if you wanted your teletype to literally log in via Telnet to a computer, like they used to over serial lines, you can. I've also got in the software a full copy of the original Colossal Cave adventure game, text-based adventure. Tells you where you are, you say go north, south, east, west, whatever, pick up a key, open a lock. It's possibly the original adventure game, I think it might be. And thankfully it's released, so I'm allowed to put the code on this. And you can actually play a classic text-based adventure game from something like the 60s on an ASR teletype, if you've got one, using this controller directly without any external stuff, just power, which is absolutely great. My grandson loved it. I said it was niche, but we've sold some. We've sold a few to people in America and in the UK. So it's not that this doesn't sell, it's just possibly the most niche board I've ever made. So that's just some of my boards. There's also the fake-in board, which we sell on Amazon. So this wouldn't be a shopping channel without some sort of special offer. So here we go. Hang on, I've got to put this back in the bag if I can find the bag now. SR33 teletype, there we go. Right, wouldn't be a shopping channel without a special offer. All of those boards should be on Tindy. If I've missed one, let me know, I'll add it. I think they're all on Tindy. If you want these boards and you're an Andrews and Arnold customer with a direct debit shipping to the UK, let me know and we will do it at 10% off whatever the pound price is on Tindy, because we don't have to pay card fees and Tindy fees and anything. So we'll do it cheaper if you want to buy it on your Andrews and Arnold account, direct debit. So that's a special offer. The other important thing to say is all of these circuit boards, they are open source designs, hardware and software. They're on my GitHub and they are sold as development boards, a component to use in your own projects. They're not sold as a final product. So they have no case, no leads. They are designed for you as a hobbyist to do what you like with them as part of your projects at your risk. So anyway, thank you for listening. I hope people actually like my shopping channel style video here, and do have a look on the store.